So, good morning, friends.
Good morning, sir.
Yeah, good
Good morning,
morning.
sir. Good morning, sir.
Sorry, it's slightly delayed, but I'll see that no all topics are covered, and I'll give much more information than what is prescribed to me also, because that will complete the the subject area. So there, though they have given very brief, but I'll give some more information also. So once again, welcome to this course. And friends, this is very important subject because the transformer is a heart of the system. The transformer is heart of any what you call any electric systems. Whether you talk about generation, transmission, distribution. If the transformer is down, then the productivity is down. The whole revenue is lost, power supply interruption. So this is the heart of system. It looks very simple, but this is the heart of the system. Whether you talk about generation, transmission, distribution, the transformer is very, very important. And this is heart of the systems. So, so keeping this asset, keeping this asset, very precious asset, without disturbance, because anything happens to this transformer, it will affect the power supply position, and it will reduces your availability, power supply availability. And also it is not like any other component, like insulator or anything like that. So these are precious, especially for transmission side, because nobody will have a transformer available, spare transformer, because it costs a lot of money, and also it needs lots of care. We cannot keep the transformer idle. You cannot keep the transformer idle because it contains oil and so many things. If you keep it that one, no, it will get deteriorated. Then again to bring it back to life, it takes a lot of time, efforts, all such things. So friends, normally, or especially a high rated transformer like 100 MVA or 50 MVA transformer, normally they don't keep spare, excepting very few. So keeping that asset is very important for transmission science. So you have to monitor, we have to monitor, when it's in service and healthiness. And nowadays there are lots of tools available to predict its life. And also what happens, you can also fairly predict that when it is going to fail also, because it gives lots of signals before it fails. It gives lots of signal, and we need to capture in terms of the chemical analysis and all such things. If you do that, we may able to say that, oh, this is in inception stage or in advanced stage, or we cannot do anything. All type of things are now it's possible, so that now it gives you a time. It gives you a time so that now you yourself get ready for that. Even if you want to have a transformer, only when you place an order with this company, they will manufacture it. They will start manufacturing. No company will not keep spare transformers, especially power transformers. So only based on your placing order only, they will start manufacturing it. But maybe the distribution transformer numbers are higher, so you can afford to have the transformer, spare transformers. But otherwise, so friends, keeping the transformer is very, keeping the transformer of failing is very important. One is power supply interruption. This will reduce the productivity of the nation. The power supply is the driving force for your development, and also it contribute directly to your GDP. So all the country, all over the world, these companies and the government, the nation, see that the power supply is available, 24/7. So you cannot afford to have any interruption. Say suppose if the power supply is interrupted for 10 days or 20 days throughout India, what will happen to your productivity, GDP? It will come down. It will come down. So all the country all over the world, they want to see that power supply is available 24/7 without interruption. Example, we always say that in a Tokyo Electric Power Company, in Tokyo, which supplies the power supply to the city of Tokyo, they say that, 4-minute interruption in a year. So this is a guaranteed, anytime, in a year, 4 minutes only, any customer will see interruption. Otherwise, he will not see the interruption. So you see what kind of, monitoring, all such things are done. So friends, so how the transformer, we need to be protected. It starts from the manufacturing, the material, it starts from there. Can anyone say that what is the life of a normal power transformer? Guess 25. Then any other numbers?
35, sir.
35,
35, sir. 35 years.
35. Somebody, any other number? Any other number?
25, sir.
Yeah. Say, yeah. Previously, the people used to tell that the power transformers, that are all being maintained very nicely. The sense, balance load, somebody is there to attend, oil testing, temperature monitoring, all such things are done, periodical maintenance done. So it says normally close to 40 years. I myself have seen a transformer, GE transformer manufactured in 1934. When I was working for the electricity board, I have seen in the electricity board 1985. So you can say there are around 50 years. That is a kind of things. So if it is maintained well, without overloading, because the transformer is subjected to lots of overloading, high voltage abuses, all such things. When it's not happening, when it's protected from all abuses, it can last for that kind of life. But in case of distribution transformers, I don't think anybody would have seen 25 years or 30 years. Because only 1 minute. Hello? Yes.
Distribution transformer has no age, sir. Hello. Hello. Hello.
Yes. Yeah. I'm sorry. There was a call from one of them. Yeah. Ask me. Yes.
Distribution transformer has no life limit, sir, because but power transformer has a light limit of 25 years, but distribution transformer has no light limit.
No. I differ with you, friends. The thing is that, see, if you see a transformer consists of what? Core. We will come back. Core,
Oil and winding.
winding, oil, then
Insulation.
yes, paper insulation. That is major important things.
Epoxy resin.
Yes. So friends, whatever you say that, one is the oil. Oil, you go on reclamation and oil filtering, that, all such thing you do that. But what will happen to the paper insulation? Will it last for ever? No. In a, in a gradual degradation will take place. That paper insulation is also have a lifetime. So that is the reason we say that if you keep your transformer without abuse, the sense overload. Overload results in what? Overloading causes what is the effect on the transformer?
Aging effect.
Heating.
Aging effect.
Yes. So the heat, what will happen is the heat will degrade the insulation properties of the material. So that is the reason we say that the transformer should be kept at their normal temperature or whatever guaranteed temperature. So as the temperature increases, the insulation, that is a major first casualty. As the temperature increases, your insulation properties of the properties of insulation will go down, deteriorate. So otherwise also, this are all components. So components, it will degrade whatever the environment you keep it, it has life, it will deteriorate. So friends, so when you keep the transformer, in a fairly good condition of not overloading, over voltage abuses, all such things, this will last for minimum is 40 years. I myself have seen transformer lasting more than 40 years. But insulation will fail. Insulation will degrade. So afterwards, you may not guarantee that. So then rewinding to be done, then rewinding done, then again, the core properties will also, it will degrade. Core is nothing but sheets of, that core consider lots of sheets in between, insulation, all such things. All will get deteriorated over a period of time. So normal sense, yes, power transformer because it is not abused. Like a distribution transformer, overload, all the three overload. Because in a substation, you monitor your transformer loading every hour. You monitor it, or you automate it such a way that it gives continuous record of your current and all such things. Now automated, so it continuously give this what exactly is going on. So you will never allow it to overload because you are monitoring it. But in case of distribution transformer, see now, of course, now the automation is taking place in a city like Delhi, where you have Yamuna Power and the Tata Power, all such things. They're all having system now, to see monitor the distribution transformer. Because the distribution transformer is nothing but a cash box. If a transformer fail, whatever the time duration, you bring a new transformer or replace it, to that extent, that customer will get affected. One is customer dissatisfaction, then next is productivity. Third one is the distribution companies loses its revenue. So now the distribution companies are started, monitoring the transformer continuously. You have a monitoring center. Now it will say that where the transformer is overloaded, where which phase is loaded, what is that level, all such things will go so that you will be able to take action to distribute the load or disconnect the load like that. So the distribution, what happened is it is a huge challenge because now only this automation, the facilities available like wireless, or wire, or you have you have to put meters. Now the now the energy meter itself can able to monitor and tell that now you can able to take the signal. Now the things are available. Previously it was not that much available. Even for last 10 years. Before that, it was not. In the last 10 years only these things are happening. Before that, it was not at all available. But in a substation environment, now you physically wire and bring the meter. So the operator will be able to watch, observe all such thing. He does it. So that way it is done. Now it is possible. We have a meter, and each transformer is having energy meter. It has, it can able to compute and give all such things, to remotely. Now wireless is available, the technology is available. You can able to get the detail, right?